And I'm Craig Brooks with Burgess. Been with Burgess about 18 years. Burgess has been around about 35 years in Dallas. We started here. We have offices across the state of Texas: Dallas, Houston, Austin, San Antonio. We're in Phoenix. We're in Colorado, Atlanta, and the Florida markets. We inspect a lot of homes every year. We do kind of our bread and butter has always kind of been the QA inspection, at the pre-drywall, at the final. We're also a third-party energy rater, and as of earlier this year, we're also an engineering firm. We can now add that to our list of services we can provide. Geotech and structural coming soon. So looking forward to see how we can help builders with a wide variety of things. But you didn't come here just to listen about Burgess, so I'll get into the presentation. If you have trouble seeing this from where you're sitting, or if you'd like to come up later and scan this so you have a copy of the presentation, please feel free. The first time I presented this information was at Sunbelt, and it was a very brightly lit room, and we had a similar projector, and it just didn't go well. So we put together the QR code, and then we were able to allow everyone to see it a little better from their seats. So again, I'm Craig Brooks, National Director of Single Family Services for Burgess. Sometimes when I do this, Chris Urbanus, the Director of our Energy Services, will kind of talk with me a little bit. But Chris couldn't make it today due to other obligations. And then, I've told you a little bit about Burgess, so we'll get right into it. The data I'm going to present represents about 160,000 inspections that we did last year in over 3,000 communities, again across Arizona, Colorado, Texas, Georgia, and Florida. And it represents work that we did on with over 270 builder clients. And this says 50 to 5,000 homes per year, but really it's 1 to 5,000. We work with custom builders, we work with production builders. We find that our services can help anyone. Every inspection is an opportunity, obviously, to improve that home, but then with a production builder, we have a lot of analytics that we can draw from those inspections that helps them to manage their people. So we're able to do a lot of different things. What we're going to do as we go through here, we'll review our top 10 from 2020, and then at the end, it's the not top 10, but it's issues that when we find it, if you don't fix it, it can really cost you down the road. But some of the big issues don't show up as frequently, which is a good sign, but they're still important to catch. So we'll jump into these. Number 10, penetration seal with flashing. Pretty basic. Zero flashing here, got a little foam around it. Going to be pretty good for your air sealing, but not so much for your water sealing, and that's where you really get in trouble with that. The code tells us that exterior walls should provide the building with a weather-resistant barrier, or a weather-resistant exterior wall envelope. And then the code further goes into explaining how that should be installed. It should be an approved material, should be installed in shingle fashion, and all such as that. But where do we find these? HVAC penetrations, electrical, plumbing, low voltage wiring, pest control tubes. Anybody that is sticking anything through the wall of your home puts you at risk for this. What are the issues that come from this? Water intrusion, probably the biggest and the most fearful in every builder's mind. Air infiltration. So in this market, we have to meet 3 air changes per hour for our infiltration rates unless we're doing some sort of trade-off. That doesn't give you a lot of wiggle room. If you take an average 8.5 by 11 sheet of paper, that's going to represent roughly 719 CFMs when you're doing a blower door test. And then if you break that down into squares, 719 squares, each one of those squares is going to be about that big. So when it comes to chasing infiltration leaks on a blower door test, we're generally looking for a whole lot of these, not a whole lot of these when they fail. So the better we can do this up front, the better we can execute it, the easier it is to pass those tests later. Other impacts, material degradation. I don't know if you've ever seen wood that's been wet and left wet long-term inside of a wall. It's not pretty. I actually have some pictures we'll get through in a little bit. And then pest infestation, because pests can get into those holes as well. We have a lot of opportunities in these homes. A lot of times trades don't understand the impact they're making to our homes as we're building them. You can see we've just cut a nice little, probably 18-inch slit there to slide these low voltage wires out. There are several holes. You've got the low voltage, you've got your gas, you've got your electric meter base, you've got your HVAC and the electrical for that, all in this photo. All of these are opportunities. You can see another one incorrectly executed. Looks like the plumber probably that may actually go back to the framer, because that pipe was probably there from our plumbing rough. We poured our foundation, we stood our walls. Now we're going to put some sheeting on the walls, and let's just make a couple of slits to get this on the wall. So there's a big education process that goes into having your trades understand and buy into executing this properly every time. Here's another one. That cardboard works great. Maybe not. There's some really good products out there, but when we install them incorrectly, we actually create as big, if not a bigger problem than what we had if we just left the hole alone. We've got some FortiFlash here at this meter base. We flashed the sides as we should. We always want to start with the jams or the base of it, and then the head. You can see we did the jam sides, we did the head side, and then for good measure we put a little bit across the bottom. But what we've done here is we've created what I like to call a funnel. I actually had one of our consultants send me a photo from a home he was inspecting yesterday and said, "See, this is why it's important that tape sticks correctly." It was raining. There were about 4 places along. It was a gable wall over a garage. There was flashing installed, and then the flashing was taped. A good tape, similar to something like a FortiFlash, but there were little puckers in it. We typically call them bird's mouths. And at every one of those, from the inside, you could see water running down the beam on the inside of the home. It's little things. It's not just using the right material, it's using it correctly. There's a lot of good material out there, but if we don't use it correctly, it's not going to do us any good. Here you can see these are 2 products that are made to help us flash our penetrations. On the left, we kind of missed it. We used a big wide one for the wall that really should be on the wall, not a column. And then on the right, this boot is really good for the HVAC line sets, but we just stuck it to the wall and didn't tape it. So it's kind of hope, right? And I've always been told hope's not a strategy. Number 9, base of wall flashing at brick ledges and corners. The code requires that the base of wall be flashed beneath the first course of masonry. A lot of masonry in this market. Just came back from Phoenix. Doesn't exist there, but you still need to address the bottom of the wall. Where is it installed? Over the face of the structural sheathing. Now, traditionally, we've always put it behind that structural sheathing. But if we put it behind the structural sheathing, what protects the bottom edge of the sheathing? Nothing. So if it's applied to the front of the sheathing, that's ideal. Should be at the base of wall, should be over windows, should be over doors. Our key impacts here: water intrusion, material degradation, and it's easily litigated. This is one that if you've ever heard any of the guys from Bush, Rudnicki, and Shelton give a presentation about litigation, this is one of the top issues that they find from the other side. When a plaintiff comes along, it's real easy to bust out a couple of bricks here and there across the bottom of the home and do very little destruction to it, and they can say real easily, they didn't do it right, now I need some money, right? So that's something easy to execute, but also easy to litigate. So something to pay attention to. Where do we see it done poorly? A lot of times, as our codes have changed, it's required more and more of the hold down type straps like this, and inevitably those get put on. The sequence that everything goes on and the attention to detail as those go on don't always allow that flashing to be laid back out. In this case, it's not. It should be laid back out and then properly mended where they're going to have to cut it. Columns, it's another place that's overlooked. That column is still the base of the wall, so we have to remember to flash those as well. Because you look at a situation like this is on a porch or patio, we've got a significant roof load on a beam that's resting on these 3 columns, and as the water comes in and the materials degrade, we have a problem. By the way, if there's any questions as I go through this, please let me know. I'll be happy to answer anything. Number 8, chase is incomplete or not sealed. Sometimes there's no chase, sometimes it's just not sealed. And then there are specific materials you can use to seal it. The code's pretty specific on that. Fire blocking shall be provided to cut off both the vertical and horizontal concealed draft openings and to form an effective fire barrier between stories and between the top story and the roof space. This is the code that tells us this has to be done. Where do we find these? All chases, any chase. Sometimes it's at ductwork, sometimes it's at plumbing, sometimes it's at fireplaces, sometimes it's to balance out a room. We had to run a duct in the corner of this room, so we're going to put a faux chase in this one just so it matches and it's symmetrical. So even that faux chase, even if there's nothing in it, it needs to be sealed. This is one that we see a lot as well. Especially in this market, we like to change ceiling heights a lot. There's very few homes that we see today in DFW that has a 10-foot plate throughout, 10-foot ceiling throughout. We like our 8-foot in the closet to save a little material. We like our 10-foot in the bedroom. We want that family room to, what the heck, let's make it 20, right? So we get a lot of opportunities where that ceiling line of one room doesn't match the adjacent room. And when we have that, we have the opportunity for the taller wall, it has to be sealed off from the upper attic or the roof space or even the flooring system. In this one, it's just that case. We've got a tall family room ceiling, and then behind this wall here, you can see where this wall actually has some fire blocking installed in it, but this sheathing that's installed on the back side of that wall does not meet the code. It's a great air barrier. Thermoply, continuous insulation, like foam sheathing, is a tremendous air barrier, but it is not an approved fire stop. So in that case, you would need to back that wall with 3/4 inch OSB, 1/2 inch drywall, something like that. Typically readily available on most of our job sites, but it's just making sure that the trade understands that and sees that. This can be a little difficult because we do have so many elevation changes in our homes. So the best advice that was given to me when I started doing inspections in homes is the guy that was training me, as he's pushing me in the back and telling me to keep walking, he was also telling me, put your head to the wall. And that's one of the greatest pieces of advice I ever found for looking for those fire blocking issues. So as you're walking those areas, put your head in the wall and look up. It's amazing what you'll see when you do that you don't see standing back from the wall. So here's another one. As I mentioned, T-ply, great air barrier, doesn't work for fire stop. This one we just haven't got the chase yet, right? We see a lot of that. Not everybody does a great job defining where those chases are in their plans. So a lot of times on site, the frame or the builder, the HVAC contractor, whoever, talk about this, or sometimes a contractor will just drop it where he thinks it and he needs it to go. So we have to come back and build that chase, seal that chase. Number 7, raw wood uncovered. On these, it kind of goes back to that exterior walls shall provide the building with a weather-resistant exterior wall envelope. So we have to make sure that any raw wood that's installed is covered with that WRB, as we like to call it, where everywhere on the exterior, see a lot at openings, like this is just going to be a brick opening on a porch, brick returns, structural wood sheathing that doesn't have its own WRB, and firewall panels in townhomes. A lot of times we have to use that. We use that fire-resistant plywood between units, and we've got a nice WRB, whether it's a wrap or a sheathing that's integrated. And then in that area, we just have this raw plywood put up there. Here's an area, the brick returns at box windows. That's a place we see this a lot. you have that 2x4 applied. No, yeah, this one's a little better. The 2x4 is applied there where the brick's going to return. And then we've got a 1x4 freeze or some type of 1x freeze here. A lot of times the bricker's just going to run that brick kind of wild into that return. And brick absorbs water, right? So over time, water will get to this unprotected 2x and it will rot out. How do we know? 10, 15, 20 years later, that freeze board falls off. And granted, is it outside of the warranty period? Probably so. But it's an inconvenience and a frustration for that homeowner long term. Another area, again, with our designs, it's not just our designs aren't complicated just in changing roof and ceiling heights, but the way we shape the exterior. So this is an odd little return around the front porch. You can see there's nothing on that vertical 2x4 there. This is what happens when you don't do it. These are actual photos that we had a builder asked us to come out and help document. This was kind of a perfect storm situation. Who remembers building homes in this market with OSB and paint on it? There was a lot of that going on. I know in the early 2000s, I remember a lot of builders that was their WRB. You threw up OSB because it was great for structure, and then we paint it, just like we would the exterior of the home. And then that was going to work. Well, that's what happened here. And then the homeowner started saying, something smells musty in this room. Just can't figure it out. And the builder kind of started digging into it. And then they said, you know what, we're going to pull the stone off the front. There was a stone elevation. So we get there and there's landscape that's about this tall. It had been a very rainy winter. It faced north. So there was a lot of moisture naturally in that wall. A lot of irrigation, watering a couple of, about every other day. So that wall never had any opportunity whatsoever to dry out. You could take a claw hammer and tap it about that hard and drive through this OSB. What ultimately happened was you had OSB with no weather-resistant barrier. You had the perfect storm facing north, a lot of rain, a lot of landscape, a lot of irrigation. And then with that stone, it left an air gap of maybe 3/4 of an inch to an inch behind it. And then nobody cleaned the mortar out as they were laying the stone. So the mortar bridged against the sheathing, and it just held water like a sponge until one day the homeowner said, something smells funny. And that's how this one was discovered. Number 6, joist hangers missing. See this one a lot. Sometimes it's a takeoff issue, an estimating issue. Sometimes it's my framer decided to frame it that way and now we got to use hangers issue. Sometimes it's an availability issue. You take a hanger like the one on the left, those you probably don't have laying around the job site. Your average 2x6, single 2x6, 2x8, 10, 12, there's usually those all over a job site. Something like this, maybe special order, maybe something that you need to make sure is on a PO, but the one on the right doesn't have one. So why do we need it? The ends of each rafter ceiling joist shall have not less than 1.5 inches of bearing on wood. So if we can't have 1.5 inches of bearing on wood, we need to have 1.5 inches of bearing on something, and that's what that joist hanger provides. Where is this? Framing members that do not have proper bearing. Ceiling joists, floor joists, rafters, beams, impacts, floor squeaks, potential life safety if it's a true failure. Like that first beam that I just showed you, it was a 4-ply LVL beam. If that tells me there's significant load on it, and if it's not carrying that load properly, that could be a life safety issue or a structural support issue. So here's an area, just ceiling joists. We like big open rooms like this. Like I guarantee if we could tear into this ceiling and look at it now, there's probably a series of beams and hangers in here if I had my guess, especially when I see this column here. It tells me that I've probably got a beam from here to there and from that wall to that column and lots of stuff hanging to it. We want big open spaces in our homes. We have to use these types of systems. We got to make sure they're installed. This is one of those that was probably kind of a job site adjustment, if you will. We have ceiling joists running in a manner that here we couldn't terminate that ceiling joist into our rafters like we did the rest of it, so our framer headed it off. When he does that, that may not be accounted for in our takeoff, so we got to make sure that we have the hangers on site to do those. Here's another thing with joist hangers. Sometimes we don't find them missing. Sometimes we find them missing fasteners. When you start looking into joist hangers, there are specific fasteners that should be used for. The manufacturer will specify a fastener or equivalent. So we got to make sure those are properly fastened. Good rule of thumb for joist hangers: if there's a round hole, it needs a fastener. There's a lot of holes in them. I mean, we'll see triangular holes, diamond-shaped holes. Some of those are optional or may not be required at all. But if it's a round hole, they need a fastener. Here's another one, an area where this roof comes out. May or may not need it, but it's a place you definitely need to look at your plan because it's cantilevered over this wall. So the designer may say you do or don't need it. So that's a place to look closely at your plans and make sure that they're there. Number 5. Plate penetration is not sealed. Most of our trades are making penetrations in the plate. Somebody has to come back and seal those. That is, it comes from the fire blocking code, and openings around vents, pipes, ducts, cables, wires, and ceiling and floor levels with an approved, they must be sealed with an approved material to resist the free passage of flame products. So fire, smoke, gases such as that. And then the material should meet this specific ASTM standard. A lot of times we'll see most of the polysil that you see works for this as long as the hole's not too big. If the hole's too big, it gets sprayed in and it falls out. So where is this? Any plate penetration, electrical, low voltage plumbing, HVAC. One of the most common that we see unsealed is where the trade made the penetration and then he rethought it. He put the hole here and he put the wire here. That's where we see a lot of these. And what happens is the insulator, they've trained him, the guy with the polysil gun, they've trained him really well to go through and find a wire and seal a wire, find a pipe and seal a pipe. They don't train him to look for empty holes usually. So it happens. So again, just like fire blocking, it's a fire hazard, a life safety hazard. Air infiltration, because that wall then communicates with the attic, right? We want to seal that off. If you look at a wall, put a blower door test on this building. If we have plate penetrations up here that aren't properly sealed, you can come to these light switches and feel air just roaring out of them. So we want to make sure that that's sealed to get that done. And overall indoor air quality. The only air we want in the home is what we invite in the home. What we bring into our mechanical ventilation so that it's conditioned and filtered. We don't want just random attic air in our homes. Some of these areas hide, like this is an area where we've dropped a ceiling, but up in the top of there is an area that needs to be sealed. Again here, different ceiling heights on both sides of this wall, so it creates some issues. A lot of wires can create issues as well. Number 4, plumbing nail guards missing at walls. So the code requires that in concealed locations where pipes other than cast iron or galvanized go through a hole or a notch in a stud, joist, or rafter or similar member, and the hole is less than 1.25 inches from the nearest edge of the member, the pipe shall be protected. So then the rest of it gets into the top that it should be. And also, as we go through top plates and bottom plates, we need to shield below the top plate and above the bottom plate 2 inches. That's what the code requires of us. So any concealed pipe that's in a hole or notch that's within 1.25 inches of the surface of that stud, impacts, water leaks, the dirty word mold, right? Structural degradation again. Let me go back to this one because This one shows how to measure it from the hole to the face. And those nice red marks is where our consultant called that out on the inspection. Make it easy for someone to find. But an area like this where there's nothing, this is a bottom plate right. We're within 1.25 inches of the surface of this. It needs a nail guard and it needs to shield at least 2 inches above the plate. This is an odd one. Don't see that one a lot. It's where the ceiling's been furred down and the plumber had to get his pipe in there, so he went through it. It's within 1.25 inches of this nailing surface, so it must be guarded because somebody's going to come along and attach drywall to there. And I've always been told that nail guards are to protect us from our worst trade on his worst day. Because most days our good trades are going to miss these objects in the wall. But on the worst guy's worst day, he will find that pipe. He will find that wire. He'll find whatever's there. Here's an area the wall was furred out. Looks like probably what we did was we called the framer and said, hey, let's fur it out. And he got it furred out. And then it's, hey, let's call an inspection. And we forgot to tell our plumber that we needed a nail guard. Sometimes these issues are sequencing. Here's another one. A lot going on in this corner, but this is a temperature and pressure relief line from the water heater, and that one is maybe 1/4 inch to the face. Behind cabinet blocks. This is another one we like to point out on our quality inspections. That cabinet block is 1.5 inches thick, right? So the code doesn't require it. We encourage our builders to always guard that because somebody tell me why these cabinet blocks are here. Secure a cabinet too, right? So we know that someone is going to be putting screws in here. When you talk to cabinet guys, a lot of times they use a 3-inch screw. If you start doing the math on the thickness of the back of the cabinet, the thickness of the drywall, the thickness of the block, yes, you can put a 3-inch screw into that. So that's why we call that out. It's something, again, it's above code, but our QA program is above code because code is the worst home that we can legally build, right? So we always encourage our clients to do this. Number 3, electrical nail guards missing at walls. Similar code language for it as the plumbing, and notice they fall real close together. One of the conversations we have about this a lot is it the hole or is it the wire? A lot of people like to say it's the wire, but the code reads it's the hole. So if it's within 1.25 inches of the, boring holes and framing members for wiring shall be located not less than 1.25 inches from the edge of the framing member. But it also addresses wires run parallel to the framing member. So as I go through it, I have a concern, but if I run a wire down the face of this, I still have a concern if it's within 1.25 inches. So both those need to be guarded. Where all concealed non-metallic cables parallel to or in holes that are 1.25 inches from the nearest edge concerns shorts, arcing, fire, potential electrocution. I missed some letters in there. Nail guards at walls. Here's some examples. A lot of times when we stack studs like this, like you can see double studs in here, there's probably some structural members, some beams above that, and we're having to put additional studs next to it or in there, so it gets a little more difficult to execute because that electrician can't run straight into the wall with his drill. He's going to have to come in from an angle, and a lot of times that's tougher to get 1.25 inches from the face of the stud. Here's another area like this in corners. A lot of times at bay windows, under windows in general, we see it a lot. This is right on the face, basically. Number 2, gaps or holes in sheathing. This one is basically a hole. It goes back to exterior walls shall provide that continuous weather-resistant barrier. Where the whole home. Who makes these holes? Everybody. Who doesn't make these holes? Are they always intentional? No. But somebody's making them and somebody has to fix them. impacts, water intrusion, air infiltration, material degradation, and pest infestation. So, in a hole like this, you can probably tell this is a garage. This is at the front of the home at the garage, and these holes were drilled. So somebody did this on purpose. However, the builder probably came in and said, you know what, that coach light needs to go over here, not over there. But nobody went back and fixed the hole. Still got to fix the hole. This is one, a lot of times with the foam rigid sheathing, it's easy to knock things through. It's easy for materials to fly from one place to another and go through. Polyseal is good to air seal it, but we need to get something on it to properly seal it for water intrusion. Here's another one. I love this one because this perfectly illustrates one of the biggest culprits in creating holes in our sheathing, the bricker. When he's installing brick ties, and it's a foam sheathing or a fiberboard sheathing, T-ply, something like that, how does he find studs? Right? And it's not too hard to drive that hammer head through that sheathing, and that's exactly what's happened here. Because he found a stud, but he also created a hole doing it. No telling what happened here. It's really not. I can't even speculate. Number one, fire blocks, fire stops missing at chases and walls. So it goes back to kind of what we were talking about with chases earlier, but it's in the walls. So like here, you've got, this is a rake, so this is a roof going up. We see this a lot, second floor, game rooms, bedrooms, typically on the rear of the home. You'll have the rafter going up, that's the first rafter of that, the roof section outside. This is attic down here, and this is wall. And we've done a pretty good job getting blocks in here. And then the plumber used his hammer drill, more hammer than drill, to knock this block out to run his pipe. And that's what happened. Instead of drilling the hole for the pipe, he knocked it out. Said, oh well, it's somebody else's problem, right? So again, when we talk to our trades and let them know about the impacts that they have on one another, we can reduce things like that. We went through this as we talked earlier with the ceiling chases, so I won't get into it too much, but where is this? Ceiling height changes, double walls, rakes, arches, stairways are common places we see these. Again, life safety, fire, air infiltration, and air quality. Our fire block got there, but we never sealed it. Electrician needed to put his wires through. Obviously he does, but our polyseal guy missed it. Still part of fire blocking. This, we have a ceiling height change. We did a good job getting fire blocks in here, but our trades didn't respect the fire block. We just kind of knocked it out, and then we kind of notched around it. Polyseal's going to have a pretty tough time getting that sealed, and that's probably where your trades are going to go to fix that. This is one that doesn't jump out at you when you first look at it, but if you notice, the tails of these ceiling joists that are married to the rafters, they come down below the plane of this bottom top plate. That means that when the drywall goes on, the wall is going to stop short of this. So that means every wall cavity here is open to the attic. So it's one of those that it doesn't jump out at you like I've got an 8-foot plate here and a 10-foot plate there, but that is a definite fire blocking issue. Stairs, the code is very specific about stairs. And when you have a concealed space under the stairs, we have to seal here. And then if the top stringers of that stairway are open into the attic, into the flooring system, those also have to be sealed. Don't see that as much. Most of the stairs I see around here run into a header, so typically the top of it's sealed. It's just these intermediate spaces that don't get sealed. Here's another one. This is a double wall. They blocked the back side of the double wall, but they didn't block the front part. So this part of the wall is still open, and remember, this sheathing is not good for fire blocking. tremendous air barrier, not a good fire blocking material. And then double wall, you can see the top of it's open to the attic. So these didn't make our top 10, but these are some issues you definitely want to pay attention to. Damage to manufactured joists. We see this a lot. Where do you see it? Throughout the flooring system, especially plumbing, electrical, HVAC, and low voltage wiring. What type of issues will you find if these are left untreated? Deflection in the flooring, deflection in the ceiling below. It could just break. You could just have a noise that you can't identify. Something like that left unremedied, that's going to break at some point, depending on where it is. If you do have this, and it does get through the inspection process, and your homeowner's in the home, and it's bad, it's significant rework, potentially putting up somebody temporarily while you go in and you cut out a section of their ceiling so that you can fix the floor above, or you cut out the floor so that you can put new beams or joists or what have you in there, and it involves multiple trades. You know, at that point we're talking framers, we're talking drywall, we may be talking a mechanical trade, we're definitely talking paint. A lot of folks get involved in that repair. Get to know the joist that you're installing. Every manufacturer has something similar to this. This happens to come from Boise. We've actually had Boise come to our office and in the field and train our consultants. We've done the same thing with Weyerhaeuser. They're the two primary joist companies we see in Dallas. So our consultants know their products well and know how to identify defects in them. This is one we just decided it doesn't really need to bear on the wall, right? We need our pipe there. So you see stuff like that. Tub drops, you see it a whole lot of tubs and commodes from the second floor. This is one that gets overlooked a lot. Anytime we rafter cut those I-joists, there is a repair that needs to be made to those. Because the top chord and bottom chord of the joist work in harmony, if you will. And if they're not the same length, they're not going to work as intended. If they're bearing out here, and I don't have this cord extended to meet it, it's not going to work as intended. There's typically a standard detail for this by every joist manufacturer. It's typically take a piece of OSB or plywood, cord to cord, and it should be X number of inches long, and it should have X amount of nails that are number 8s or whatever they are, and they should be clenched and a bunch of stuff like that. But it's really simple to execute and something that's important to make sure that these systems work correctly. Another thing, holes too close to one another. Most of the joist manufacturers will have a rule in there that says when you put two holes, if you want to put two holes close together, you have to go twice the diameter of the largest hole before you make the second hole. So if I've got an 8-inch hole in this joist, I need to go 16 inches before I can make another hole. And then that hole needs to be 8 inches or less, or it becomes a hole I need to judge from. And also, these holes have a distance from a bearing point, so that's something you need to know too. A lot of times you can make a small hole just about anywhere in the joist, but the bigger the hole, the more attention you need to pay to that. This is really crucial for HVAC contractors because everything that they do is a big hole typically in these joists. Brick on wood flashing. So we're going to have brick going up this wall and up this rake, and you can see shiny OSB decking. There should be some flashing there. The reason for this, flashing shall be located beneath the first course of masonry and at other points of support. So we're supporting brick there, so it must be flashed. Where rakes, box windows, shed roofs, why? Because of water intrusion and material degradation can become a significant structural issue because you've got a lot of weight in these areas a lot of times. So any area like this where we're going to have brick going over the roof, we need it. Small return here. Why do we need it? We actually had a builder call us out and ask us to do some testing on this one. This home was just about finished. Big rainstorm came and it leaked. And it's because they did not have brick on wood flashing. Kick out flashing. This is another one that gets overlooked a lot. This one, if you look at it, we've got two little small pieces of roof here, right? Each one of those is no more than 3 feet. But if you look at the way this roof drains, you've got this entire front hip here that hits these two valleys and comes down these short pieces. And you can kind of see there's a little bit of discoloration on the face of the stone there. That's from water running down the face of it over time. If we have kick-out flashing here, it's going to dump it all into the gutter. This didn't, so it was running down the face of the stone, soaking through the stone, getting to the sheathing behind it. So flashing shall be installed at wall and roof intersections, and that's exactly what we have there. Where rates, head walls, and transitions impact water intrusion, material degradation. So this is a place too, with the light in here, it's a little difficult to see. This is a home under construction, and you can see water's run down this rake, and there's a wet spot on that little soffit piece right there, right into it. Here's another one. You can see it had rained. I took this one day a few years back. It had rained really hard overnight and into the morning, and I was out there that afternoon and noticed this. You can see that how the water soaked up into the siding, and then it's soaked into here to where it's just rushed down the face of that wall. Not a problem today, but will be a problem at some point. Okay, so back to this one. As we tore this one apart, this is actually a home that belonged to one of our employees. And it kind of, the same similar symptoms to the something smells musty, but better than that, that's my daughter's room behind that window, my baby girl. And there's water in there. What's going on? So we went over there, we helped him find the trades and helped him tear it apart and put it all back together. But we found this OSB, and you can kind of see there, it's nicked a little bit. Same thing, you can take a hammer and easily drive it through there. After we drove it through there, I tore all of that out by hand. It crumbled in my fingers. So that's the material degradation we're talking about when in this case, we've got a couple of things going on, right? We don't have our kick-out flashing, which that is what led us to the bigger problem of not having a weather-resistant barrier behind our over our sheathing. So we dig in and we take the sheathing off and we find more problems. As you can see, this is an LVL garage header, and it's significantly discolored. And these studs here are significantly discolored. All of that right there, that's a section, well, that's 1.5 inches deep back to there, and that's about 1.5 inches high. I was able to dig out of that LVL with my bare hands before I got to solid framing again. And then you can see this almost looks like it's been on fire. The way that it's reacted to the wetting cycle over and over and over. But yeah, that was an interesting exercise because we got to do some forensics on a home we didn't originally inspect, but we had the ability to go into, so that was kind of interesting. Another big one's window flashing. A lot of times here too, we get really good products, but we don't install them correctly. The code tells us how to do this. We must do it. There are lots of recognized methods for this. What I always say is understand the windows you're buying. When you buy a window, have a conversation with the manufacturer, read the installation instructions, talk to your trades about it, and make sure they understand the way that it's intended to be installed. All windows, water intrusion, material degradation are our key impacts. This is a big one we see a lot. The bottom flanges of the windows covered. It's had a lot heard over my career in this industry with windows. It's not if they leak, it's when they leak, right? And we want the water to be able to get out. And if we do this and cover that bottom flange, we've created a dam that will prevent that water from getting out. And then this is one, just the side of the window not flashed. Top of the window not flashed. And that's it. Do y'all have any questions? Yes, sir.
Framing around garage doors. I mean, most everybody just uses like 2x8s or something raw wood.
For the, yeah, well, those, I guess you could say that is, you're talking about like the garage door trimmers. It's a serviceable item, so that doesn't necessarily have to be, it's those items that are going to be behind something else that you're never going to see and you won't be able to service. But I have seen more builders go into a treated material there or a cedar or something like that. Anyone else?
On that repair that you were mentioning for that employee, do you know what the estimate was to get all that fixed? Let me ask you.
Probably about $5,000, 5 to 6. Which some of that was calling in favors and things like that. So I mean, the random homeowner off the street, home over 10 years old, that's all coming out of your pocket. And it's, if you can find somebody to do it, I mean, it's you get a remodeler to come in and do that, and I'm betting it's 15 to 20. Just guessing.
Kind of what I figured.
Mm-hmm. I'll leave this up if anybody wants to scan the code before they leave. Get a copy of the presentation. You're more than welcome to. I've got some business cards. If anybody has any other questions they didn't want to ask in front of the group, I'll be happy to answer those. And thank y'all for your time.
Thank you, Corey.